Hey, what's up, guys? It's me, Bonnie, again with some tutorial video on Matlab, our famous software, a prominent software. Because Matlab is a software package for high performance computation and visualization. It has lots of built-in functions and toolboxes. A Matlab operation can be done in command prompt window directly or with the help of an M file. It's a file type of Matlab. M files are smoother because of its feasibility, editing options, changing variables, and uh, portability. You can port the file from one place to another with the help of pen drive or flash drive. We can share it to anyone. Here I use Matlab 13 version 2013. It's a little bit older version comparing these days because already they launched 2017 version, but I feel more flexible using this, so that's why I use it. And today I'll show you how to plot a 2D graph. In this video I'll show how to draw a simple graphical representation of a trigonometric function using both this command window and an M file. The most fascinating feature of Matlab is as soon as you create any array of function, whether large or tiny, you will get the data in the workspace box. This data will help a lot during any big project or analysis. So let's get started how to do this. To plot and graphical representation, you must have to know about some built-in commands and syntax like plot. Say I am writing here plot, this one, or something like axis. There are another one like semi-plot, etc. So this is our command window, command prompt. We mostly call it command prompt. So before going deep into this section, you have to learn about 2D graph. Later I will discuss on 3D plots in another video. First, we initiate an array of sequential numbers with a command, a famous command, linspace, line space. And the range, actually, let's call this as a variable, say x equals linspace, say from 0 with the time gap 2 pi. Pi is an built-in function, and the last one is 100. So my range is 0 to 100 with 2 pi gap or variations. This is a sequence. It seems like a for loop when you run a program in C or C++ or anything like that. And then there are famous loop options called for loop, and the for loop syntax is just like this. This is the initial condition 0, and here is the increment or decrement. That means here is the gap, increment gap, and 200. So 0 to 100. Obviously this is an incremental function. So we call this line space, and any line you write in this Matlab program or in command prompt or in an M file, you must have to execute with a semicolon at the end of the line. So I put a semicolon, and as soon as I press enter, so look, our workspace has an array that is 100, 0 to 100, so 100 boxes already the program created. Now when I plot a say sinusoidal wave, I have to write y. I call another variable named y equal to sine bracket. Here is our x semicolon. Look, the y function is, the y table is created already. Now the simple option plot with respect to, look, when you write plot, the built-in help function or built-in help materials of Matlab will show you many options of this plotting, of this plot function. Look here, you can easily generate plot y, simple y, only one, that is default, by default, or you can use the xy plot, or the actual 2D plot, and many more. Even these are called syntaxes, even the line color, the line width, the line depth, etc. At the figure. So for, as we are in an initial condition, we'll just put x and y. Put on the semicolon again. Look, the figure appears, and this is the pure sinusoidal wave. You know, a sinusoidal wave, the sine range is the top is 1 and the bottom is -1, and here are the values, -1 to 1 the range. This is pi by 2 or 90 degree, and this is 3 pi by 2, that means 270 degree, and here this one is 360 degree, that means 360 degree and 0 degree are same. And in this level, here is probably 180 degree, because sine 180 is 0 also. It's very simple to draw a figure, a trigonometric figure, or any figure with this command, with this plot command. But if we want to add another plot in the same figure, you can create it easily. So first, to do that, say I call another function like y1, another variable like y1, and I call this as cosine of x. And to add another plot in the same figure, you have to use a command called hold on. Just hold on, no semicolon will be needed. It will appear again, and now the same command plot x, and now we call y1. See, so there are two functions. One is sinusoidal and the other is cosine graph on the same figure. To distinguish between these two lines, you can use some syntaxes, like after the plot x, y1, you can use another comma and then inverted, single inverted comma, and here you use two hyphens, that means dashed line, and a color, like for red you use R simply, and close the inverted comma. So it looks like purple. When it looks like purple, that means the syntax is well and the syntax is correct. And if I enter now, the color is changed. You see, the color is changed. This is the red, and this one is the previous sinusoidal, and this is cosine. This is the enlarged version of that figure. You can save this figure from file save as, and there are many options, like you can save it as this is Matlab figure file that is quite good, quite well for the beginners, but you can use as bitmap, BMP file or EPS file, more clear, and the JPG format or PNG format, etc. So there are many image formats you can save the figure and use it in your thesis or in your paper or any other thing. So let's close this. So from the command prompt window you can do this, but what if we use the M file? Let's check the same command I will use in an M file. So first of all you have to click on the new script at the left top of the Matlab software. Then window appears called editor untitled, because you still don't do anything. So now the same command I will write here, like x equals 9 space 0 with a gap of 2 pi 200 in the semicolon, and then same y equals sine of x others semicolon, and y1 equals cosine of x. Now I plot x, y, and with the color or anything I use here, say a hyphen and a triangle shape, just like that, and color is R, red. Hold on, and then plot. This time I use x, y1, and the color should be hyphen or another hyphen, and say I use blue. Already by default you can see any graph in blue. So this is our program, and let's check it how it works. Just click on the run. When you press run without saving in your file, then it will appear that you have to save this file. So I save this on the desktop, and the name I keep to remain same, the content name, and save. So it will show that you change folder. Nothing to do, just press add to path and see it appears like that. This is the total graph, the combined graph. When you expand it, it will appear like that. You can edit the program more, like hold off and run again and check the figure again. So continuously you can do this. I changed something here and again run. So look, it was something mistaken that I press an O there, so an O is invalid. That's why it didn't show, but now it is showing the total function. This is our cosine function and this is the previous sine one. So with the help of this M file, you can run a program or you can draw a figure. And if you want to add more figure here, then just cut this hold of line and call another function, say y2 equals, and you use here like exponential function, exponential like exponential x, semicolon, then plot x and y3, y2, so save it and run again. So 3 graphs, because exponential is a huge term, that's why it will show like this. If we expand the total figure and zoom it in a particular area, so look, it's a huge function. It's a huge one. So I edit this again. So exponential 0.02x. Save again and run again. You have to put multiplication sign here and a point because it's an array. Save it and run again. Now look at this, 3 functions are here in the same figure. So viewers, we can draw any 2D plot with the help of this M file. So it is better to use an M file to plot something, because you can edit this and you can calculate, or you can generate the graph and experiment more and more. In the next video I will show you more about this 2D plotting with some more functions. Here I used only the trigonometric function, but later I will show many complex equations and many numerical analysis in the next tutorial. So for now, stay safe and keep researching more and more with this Matlab. And any queries, just feel free to ask me anytime. I will support you anyhow. Thanks for watching this.